All right, everybody, welcome back to Unit 2, Lesson 4. So, we're just going to do a bit of cleanup this lesson. So, if you understood absolutely everything from last lesson, then you should be fine. But since there is some things that are left to discuss, I will just do some cleanup with you guys. Starting with this. F of x is going to be equal to x cubed plus x squared plus x. This is the first rule we're going to talk about, the sum rule, the addition rule. Each of these components will be individually derived. That's basically the entirety of the rule, is that each of these components will be individually derived. Meaning, if we subtract let's just make that x. Then each of these components, again, will be individually derived. Excuse me. Yeah, no, my bad. There it is. Remember, any constant, always 0. Any constant derived will always go to 0. Will always be 0. Alright, so that's basically what that is. Those are what they call the sum and difference rules. And now let's talk about a little bit more cleanup related to derivatives on these types of functions. So f of x is going to be equal to a constant c x squared. So what will f prime of x be? It'll be 2cx. This is important to note. The power rule leaves constants alone. Whenever we derive, not just the power rule, whenever we derive something with x, or something with a variable, we leave the constant alone at first. See what we did here? We took the c, we put it down, and then we multiplied it by the 2 that came down, and obviously this is going to be 2 minus 1. That's going to be that power. Alright, so now that we talked about that, let's talk about some applications that you'll see this in. If you understand everything up until this point, the applications are pretty easy. We will go over this more in the next lesson as well, but I just want to touch up on this right here, right now. So the limit as x approaches c of f of, let's say, x plus 3 cubed minus, we'll say, minus 27 over x. If this looks pretty familiar, then it should be. It should not be x approaches c, by the way. This should be x approaches 0. Right? If this looks familiar, then yes, it absolutely should look familiar. Let's go with a little simpler of a function. Let's go with squared. Just because this is going to be a more basic lesson. We'll go 9. All right, let's just go. We'll start you off with an easier example. All right. So x approaches 0 of this. So obviously what we're going to do here is what you would normally do is you would go limit as x approaches 0 of x squared plus plus 6x plus 9 minus 9 over x. And then you would do, that's going to be equal to the limit. So x approaches 0. Excuse me. Let me write that on the next line. Is equal to the limit x approaches 0 of x squared plus 6x over x. Therefore, meaning that cancel, cancel, cancel. It's equal to x plus 6. Right? So that's how you would normally do that. But if you had the derivative instantly, what you could do is you could just say, oh, let me see this. F of x is going to be equal to x plus 3 squared. All right, so what's that equal to? That's equal to x squared plus 6x plus 9, right? I know that. So if I just derive that, 2x plus 6, and then I plug in 0, well, it should, this will evaluate to 6. Excuse me. I think I did this one wrong. Let me just redo it for you all. So x squared plus 6x plus 9 minus 9 for x. That's going to be equal to the limit of x approaches 0 of x squared. That'll be equal to x plus 6, right? Which is just going to be equal to 6. Meaning f prime of 0 is going to be equal to 6 the same exact way. Also, that should be, yeah. Yeah, that seems about right. And as you can see, the limit didn't evaluate the same way, but it evaluated to the same exact answer. So if you want to find that derivative, what you have to do is you have to they'll sometimes give you problems like this, right? But it'll be more tricky. It'll be more complicated functions sometimes. Sometimes functions that you will not always be able to evaluate. Like, for example, let's say x plus 4 cubed minus 125, and then x minus 1 as x approaches 1. Right? So we're going to take this, and then we're going to obviously see that this is going to be, this function, x plus 4 cubed, is going to be our f of x. And if we know that, we can pretty easily just expand this and get our answer. I'll do it in a bit of a different way, just because I feel like it. Don't use this method right now. This method is unnecessary. But in the future, you will know this. But for now, just use them. Expand this out and then do it that way. 16, which is going to be equal to 3x squared plus 12x plus 48, which is what you should have gotten, unless I made a mistake, which I will check now, and I did not make a mistake. All right. So that's one of the ways they can get you. Another one of the ways is by using the limit as h approaches 0 of x to the 4th plus h to the 5th minus x to the 4th to the 5th all over h. Right? Now, this seems a bit complicated, but it's pretty obvious, right? This is going to be your function, x to the 4th to the 5th, and x to the 4th to the 5th is obviously just going to be x to the 20th. So that means f of x is going to be equal to x to the 20th. F prime of x, you just use the same power rule that we've always used before. 20x to the power of 19. All right. So those were two methods you could use. again, they'll give you tables, they'll give you graphs, they'll give you a lot of different methods, and they'll try to trick you. They'll try to make you think it's not the derivative, but just stick to what you know. Like if a limit looks like the limit as h approaches 0 of f of x plus h minus f of x over h, just check, and like a lot of the time it will be that. Or if the limit is x approaches c of f of x minus f of c over x minus c, if it's like one of these two, then definitely check for them, because you can solve the function pretty instantly that way. All right, that'll be all. We're gonna cover 4 new derivative rules tomorrow. So 4 new derivative rules, and I will see you then.